Applications of resistors, potential dividers. Resistors may be used to obtain different voltages from one supply. The arrangement of resistors is called a potential divider. The value of the resistors may be chosen to give any value of output voltage, V0, between 0 volts and the supply voltage, Vs. The voltage of the supply splits between the two resistors in proportion to the values of the resistors. Therefore, the output voltage V0 is the same fraction of the total voltage Vs as resistor R2 is of the total resistance R1 plus R2. This relationship is easier to understand through the ratios V0 over Vs equals R2 over R1 plus R2. We can therefore calculate these output potentials and compare them experimentally. First of all, we have a supply voltage of 6 volts with R1 equal to 1 kiloohm and R2 equal to 2.2 kiloohms. So if we calculate R2 over R1 plus R2, it's 2.2 kiloohms over 3.2 kiloohms, and it gives us 0.69. So our output voltage will be 0.69 multiplied by the supply voltage, so 0.69 times 6 volts, and that equals 4.14 volts. So we can now take the voltage of R2 to verify this experimentally. So it's 4.14 volts. Our next setup has R1 equal to 2.2 kiloohms and R2 as 1 kiloohm. The supply voltage is again 6 volts. If we calculate, we have R2 over R1 plus R2 is equal to 1 kiloohm over 3.2 kiloohm, which equals 0.31. So our output voltage is 0.31 times the supply voltage, so 0.31 times 6. So that equals 1.86 volts. So we can take a reading to see if this is correct. And we're pretty close, 1.87 volts. Now we have R1 as 1 kiloohm, R2 as 10 kiloohms, and the supply voltage as 6 volts. Calculating R2 over R1 plus R2 gives us 10 kiloohms over 11 kiloohms, which equals 0.91. And if our supply voltage is 6 volts, V0 equals 0.91 times 6, which equals 5.46. And again, we can verify this by taking voltage across R2. So again, we're pretty close again, so 5.45. So again, we have R1 is 1 kiloohm and R2 is 10 kiloohms, but we're going to turn down the supply voltage to 4.5 volts. Again, doing our calculation, we have R2 over R1 plus R2 equals 10 kiloohms over 11 kiloohms, which equals 0.91. So then we multiply the supply voltage by 0.91, so it's 0.91 times 4.5. So we should have an output voltage of 4.10 volts. And again, we're going to verify this on the voltmeter. So we're pretty close again. So if you round it, it's 4.1.